So good evening. My name is Joel Towers, and I am the Executive Dean of Parsons School of Design here at the New School. And it is my pleasure on behalf of the university, and in particular the Schools of Public Engagement and the Tishman Environment and Design Center, to welcome you to the second annual Jonathan Schell Memorial Lecture. I'd also like to thank our longstanding partners at the Nation Institute for the many programs that we have produced over the years together. And in particular, we're honored tonight to be presenting this talk together with the Gould Family Foundation. I also want to thank my colleagues Mary Watson, the Executive Dean of the Schools of Public Engagement, and Michelle DePass, the Dean of the Milano School of International Affairs, Management and Urban Policy, and also the Director of the Tishman Environment and Design Center, which is a place here at the New School where we really work at the intersection of design, policy, science, and social justice. And I'm particularly wanting to thank them because they should have or could have been making tonight's introduction. But when I found out from Michelle and Mary who our speaker was, I very excitedly asked them if I could do the introduction, because I am a huge fan. And while I will leave it to my next colleague to make a formal introduction of Elizabeth Kolbert, I do want to say that the work that she does, her writing, which really speaks, that would be one of those cell phones. Her writing really speaks with urgency and with clarity as she highlights the very particular challenge of our time, and that is the relationship between humans and the natural environment. And the world that we have designed, and when I say designed, I mean design in the broadest sense, design as the action that is the result of human imagination. A world that has been designed to be the way it is and which is deeply broken. And that urgency and that necessity to focus on the fact that we have built this world to be the way it is and that we must collectively build it to be different is what I take from the extraordinary work of Elizabeth Kolbert. And so it is my great pleasure to say that she will be introduced in a moment. I'd also like to thank, by the way, one last colleague without whom none of the work here could be possible, which is Pam Tillis. And to introduce and bring to the stage a journalist, an author, a Dorothy and Louis B. Coleman Center for Scholars Writer Fellow, and most importantly for tonight, a Nation Institute Fellow, Eyal Press, to the stage. Please welcome Eyal.
Good evening. Thank you for the introduction. And I'm going to read a short statement, promised to be short, about Jonathan and the Nation Institute and this lecture series you're at. And then I will say just something personal about Jonathan Schell and Elizabeth Kolbert. The Jonathan Schell Memorial Lecture Series on the Fate of the Earth was established last year by the Nation Institute and the Gould Family Foundation in memory of a longtime New Yorker writer and then Nation Institute Fellow and Nation Magazine columnist, Jonathan Schell. I'm also a Nation Institute Fellow, as you just heard, and on behalf of my colleagues, I'm very honored to welcome you tonight. Today we are both proud and disheartened to say that the lecture series feels more prescient than we imagined at its conception, and we cannot think of a time when reminding people of Jonathan's voice and work is so needed. We are honored that the series has found a supportive home at the New School, and we are grateful to everyone who joins us tonight. Thank you to our steering committee, who I imagine are out here, as well as to Jonathan's family and friends who are also here this evening. We'd also like to take a moment to thank Edwin Matthews of the Gould Foundation, whose commitment to creating this series has never wavered. And finally, we remain always grateful to our beloved colleague Jonathan, whose kindness was as notable as his intellect. As Jonathan would remind us, quote, "Because everything we do and everything we are is in jeopardy, and because the peril is immediate and unremitting, every person is the right person to act, and every moment is the right moment to begin, starting with the present moment. On a more personal note, I had the pleasure to know Jonathan when I was at the Nation Institute, and he was there, and to experience his graciousness, his intellect, his kindness firsthand. I imagine the list of young writers and reporters he inspired to enter the field of journalism is long. I'm one of them. Just after graduating college, I entered a used bookstore and saw a copy of his first book, his first New Yorker article, The Village of Ben Suc, a brilliant and devastating account of a US military operation in Vietnam that was both gracefully written and, like nearly everything he wrote, uncomfortable and disturbing to read. Jonathan wasn't just a reporter, he was an intellectual whose work explored large moral concerns and large moral problems that implicated all of us, which made his writing both deeply compelling and, again, uncomfortable to read. Before coming here, I read through some of his old pieces and came upon one that is both illustrative of the qualities of his work and oddly timely. It was written in 2002 on the eve of the impending invasion of Iraq. It was titled The Case Against the War. It appeared in The Nation. And Jonathan argued in that piece that the war was being sold to us on a false premise. Not the false premise that Saddam Hussein had weapons of mass destruction, which a few people were pointing out, but rather the false premise that invading a country in order to stop the spread of weapons of mass destruction would make the world a safer place over the long term. As Jonathan argued in this essay, on the contrary, force can only exacerbate the problem. If you want to avoid regime change by the United States, build a nuclear arsenal. And by the way, much of that essay was not about Iraq. It was about North Korea. So here we are, 15 years later. Jonathan was obviously greatly concerned with the future of the planet, the fate of the Earth, as he put it in his best-known book. Given this, I can't think of a more appropriate person to be giving a lecture named after him than Elizabeth Kolbert. For the past 2 decades, Elizabeth Kolbert has been reporting on the catastrophic effects of climate change for The New Yorker in dispatches from Greenland to Miami. She's the author of numerous books, including most recently The Sixth Extinction, which won the Pulitzer Prize. Like Jonathan, her work is centrally concerned with our capacity for self-destruction. Climate change is not only laying waste to coral reefs and innumerable species, she shows in her most recent book, it is also imperiling humanity. Also, like Jonathan, her lucid writing is uncomfortable to read, since it raises large moral questions that implicate all of us. In one of the chapters of The Sixth Extinction, to me the most harrowing, about the acidification of the oceans, she points out that every day, each American, meaning every single person in the audience, myself included, pumps 7 pounds of carbon into the sea. That is something we don't like to think about, but something we can't ignore thinking about. So please join me in welcoming our speaker tonight, Elizabeth Kolbert.
Thank you. Thank you for that introduction, and thank you all for being here tonight. It's really a tremendous honor to be up here delivering the second Jonathan Schell Memorial Lecture. And it's a particularly tremendous honor because last fall's lecture was delivered by Bill McKibben. And I sadly did not have the privilege of knowing Jonathan Schell personally. I met him only once, very briefly, when he was a visiting scholar at Yale. But like pretty much all of the journalists of my generation, as Eyal just spoke to, I was very much influenced by his work, and especially by The Fate of the Earth, which I recently reread, and which is just as rich and vivid and chilling now as when it was first published almost 35 years ago. I have been fortunate enough to know Bill McKibben, and Bill was so precocious that even though we are about the same age, I've also been very much influenced by his work. And I've watched with something very close to awe as he's moved not exactly away from journalism, I guess you would say, but beyond it, to build a global movement demanding action on climate change. And I think it would be very hard to overstate the impact that Bill has had through his writing, his speaking, and his activism. Bill and Jonathan were colleagues at The New Yorker and also friends. And there are many qualities that their work shares, including, as all of you who are familiar with their work know, a fierce moral energy. They share the conviction that exercising our imagination is an ethical responsibility, that we need to look beyond ourselves, beyond our own experiences, beyond even what could be experienced in the here and now. They urge us to take the broadest possible perspective on the world, the perspective of historians of the future, the perspective of generations waiting to be born. Because only then can we really appreciate the enormity of what's at stake in what to us counts as the present moment. When I was asked to deliver this lecture, the prompt that I was given was to address the fate of the Earth. One possibility that obviously occurred to me was the possibility suggested by Jonathan's The Fate of the Earth. In the age of Donald Trump and Vladimir Putin, the possible use of nuclear weapons has crawled from the dustbin of history, John Mecklin, the editor of the Bulletin of the Atomic Scientists, wrote back in June. In June, North Korea had not yet produced a nuclear bomb small enough to fit into a missile. Donald Trump had not yet threatened to unleash on North Korea fire and fury like the world has never seen, and North Korea had not yet launched a rocket over Japan. In June, Trump had not yet started to tweet about Rocket Man, and Kim Jong-un had not yet called Trump a dotard. Also, in June, we had not yet learned that Donald Trump had proposed a tenfold increase in our nuclear arsenal, prompting his own Secretary of State to call him a moron. Since June, the Trump administration has let contracts for building a new generation of advanced nuclear-tipped missiles, the total price tag for which is eventually expected to come to $25 billion. And when these upgrades were originally planned back in the Obama administration, they were supposed to be accompanied by commitments to nuclear arms reductions. But now it seems likely, very likely, that we will get a new generation of nuclear weapons without getting the arms reductions. So we are doing exactly what Jonathan warned about. We are being either too complacent or too self-protective or perhaps too distracted to envision what the use of nuclear weapons would actually mean. Many experts warn that we are sleepwalking into a new arms race with Russia and China, this one with even more sophisticated missiles. What could possibly go wrong? Another possible way to get at the fate of the Earth, of course, is to talk about climate change. Though it would be wrong to say that climate change caused the recent string of devastating storms, Harvey and Irma and Jose and Maria, the damage from these storms, which is now estimated at more than $200 billion, was certainly made worse by it. Hurricanes draw their energy from the warm surface waters of the oceans, and when Harvey swept over the Gulf of Mexico, surface water temperatures were as much as 7 degrees higher than the long-term average. And whether it's dangerous storms or droughts or flooding or wildfires like the sort that are raging right now in Northern California and that have already claimed at least 17 lives, we are already seeing the destabilizing effects of global warming. And whatever small progress on climate change was made during the Obama administration is now, as you all know, being reversed by the Trump administration, which has nominated fossil fuel industry lobbyists or their equivalents to lead key agencies. Just yesterday, the EPA administrator, Scott Pruitt, signed an order to initiate the repeal of the Clean Power Plan, which was central to the US's commitment to the Paris Accord, which of course the administration has also decided to abrogate. All of which is to say that October 2017 is a scarily opportune moment to talk about nuclear war, or to talk about climate change, or to talk about nuclear war and climate change. But I'm going to try to do something slightly different tonight. Instead of looking at the fate of the Earth from our anxious perspective, from a human perspective, I'd like to try to look at it from the viewpoint of the millions upon millions of non-human species with whom we share this planet. This, I think, represents a different kind of imaginative exercise. It requires us not to imagine events that might happen or have not yet happened, but to look at events that have already happened through different eyes, or perhaps even without eyes, since so many of our fellow creatures lack them. On some level, of course, it's impossible for us to do this. It's impossible for us to take such a radically different viewpoint. But on some level, it's also impossible for us to really imagine the after effects of a nuclear war, since to do this, as Jonathan pointed out, one would have to take the perspective of a casualty. So we will always fall short in these exercises, but I still think it's important for us to try, so I hope you will indulge me this evening. I'm going to start out with an individual animal who went by the name of Tuffy. So Tuffy, as I understand it, and I never had the pleasure of meeting him personally, though I did meet one of his siblings or perhaps cousins, was a very charming fellow. He was born in a cloud forest above the town of El Valle in central Panama. And this is a really beautiful and rugged area that's unusually rich in biodiversity. And specifically, Tuffy was born in a tree hole. His mother deposited her eggs in a tree hole that was filled with water, the way everything in a cloud forest is filled with water. And then when Tuffy and his siblings were tadpoles, their father took over and cared for them. So up in the tree hole, there wasn't much for the tadpoles to eat. So Tuffy and his sisters and brothers sustained themselves by quite literally eating the skin off of their father's back. So Tuffy was living in the cloud forest in 2005 when he was found by a group of herpetologists. And he eventually came to live in the botanical garden in Atlanta. And that's where he lived until the fall of 2016. And he was presumably a pretty typical representative of his species, which is called the Rab's fringe-limbed tree frog. And this species was discovered only in 2005, and it was named only in 2008. And the reason it was discovered, which is the same reason that Tuffy came to live in Atlanta's botanical garden, is that biologists were desperately trying to catalog the amphibians in central Panama before they disappeared. They'd watched in horror as a plague had swept through the western part of the country, wiping out the frogs and toads, and they could see this wave of death was moving east toward the central part of the country, which is home to some really spectacular amphibians, including this species, the Panamanian golden frog. So Panamanian golden frogs are very beautiful, as you can see, and they used to be considered a symbol of good luck in Panama. Their images were often printed on lottery tickets. So these biologists, some were American and some were Panamanian, were, as I said, trying to catalog what was out there before it was lost. And they were also collecting animals with the idea that if they could save breeding pairs, they would create a sort of ark. And in the case of the Rab's fringe-limbed tree frog, only a handful of animals were caught before the scourge hit. Researchers managed to collect a few females and a few males, including Tuffy, but although they were brought together in various combinations, they never produced viable offspring. Meanwhile, efforts to collect more members of the species were unsuccessful. The frog, the Rab's fringe-limbed tree frog, has a very distinctive call that sounds like a dog barking. And though many man-hours were devoted to listening for it, its call has not been heard since 2007. So the last male Rab's fringe-limbed tree frog, the last female frog died in 2009, and the second to last male in 2012. And that left just Tuffy. And when he died in September of 2016, it's likely that the Rab's fringe-limbed tree frog went extinct. A notice of his death ran in the New York Times, and it ran under the headline, "A frog dies in Atlanta, and a world vanishes with it." And the cause of this extinction, the cause of this amphibian plague that was running through Panama, was a fungal disease that goes by a few different names. Sometimes it's called chytrid, and sometimes it's called BD. And no one knows exactly where the disease originated or how it moved around the world, but it showed up on different continents almost simultaneously, which means that almost certainly it was transported around the globe by people. One theory is that it was carried around the world on African clawed frogs. African clawed frogs were used in the 1940s and 50s for pregnancy tests. The frogs would be injected with a woman's urine, and if by the next day the frog had produced eggs, then you could tell that the woman was pregnant. And African clawed frogs, it's now known, can carry this disease around and not be affected by it. So that's one possible way it was moved around the world, but this is still a subject of very active research. So seen through the eyes of Tuffy and his ilk, and frogs have very interesting eyes. They can see colors in the dark, something that we can't do, and something that it's possible that no other animals can do. BD, this fungal pathogen, looks a lot like germ warfare, like a biological weapon designed to spread and inflict maximum damage. One of the most disturbing sections of the book, The Fate of the Earth, in my view, is the chapter titled Second Death. And in that chapter, Jonathan Schell asks us to contemplate the complete annihilation of humanity. We have always been able to send people to their death, he writes, but only now has it become possible to prevent all birth and so doom all future human beings to uncreation. This is what the spread of BD has done to the Rab's fringe-limbed tree frog. All future generations have been doomed to uncreation. And it's not just this one species. Many frogs and toads have been doomed by the same pathogen. Gastric brooding frogs were these remarkable animals that gestated their young in their stomachs and then gave birth through their mouths. There were 2 species of gastric brooding frogs that lived in Australia until BD swept through, and both are now extinct. The same goes for the sharp-snouted day frog, also native to Australia, and the golden toad, which is not related to the golden frog, but which was native to Costa Rica. Many populations of frogs in North America have collapsed owing to this disease, and several species have been driven, if not all the way to extinction, then very, very close to it, including this fellow, the Wyoming toad, which is now classified as extinct in the wild. All in all, BD has been implicated in the extinction or the catastrophic decline of at least 200 species. Meanwhile, BD is just one of several pathogens that we can be pretty confident have been moved around the world by people that are now having devastating biological weapon scale impacts. Another is what's become known as white nose syndrome. I'm sure most people in this room tonight are familiar with that. It was first detected, this disease, which affects bats, was first detected in upstate New York in 2007, near Albany. And since then, it has killed millions and millions and millions of bats. What you're seeing in this photo are bats with white nose, that whitish powder, which is sometimes jokingly compared to, looks like they're snorting coke. That is the fungus. And white nose is imported from Europe. We're pretty sure about that through very careful genetic tracing. And it was probably brought to New York on the shoes or on the backpack of some unsuspecting tourist. And over the last decade, white nose has spread to 31 states, so from upstate New York to 31 states and 5 Canadian provinces. And last year it was found in Washington state, so almost 3,000 miles away from upstate New York. And the problem with white nose syndrome, which is also the problem with BD, is that once it gets into the environment, it can spread on its own by putting out spores, or it can be spread by other animals or by people. This is a shot of me and an official of the Vermont Fish and Wildlife Department, Scott Darling, and we are standing in a cave that was a favorite spot for hibernating bats. So here in the Northeast, a lot of our bats are hibernators. They go into a very, very deep torpor over the winter in caves or sometimes in abandoned mine shafts. So here we are. In this photo, we are in a cave in southern Vermont that was the largest bat hibernaculum, as it's called, in New England. So about 300,000 bats used to congregate there and spend the winter. And it's very dark in this photo, so you can't see this, but we are standing on a carpet of dead bats, several inches thick. And over the last decade, the number of bats hibernating in this cave has dropped by over 90%. So, of course, it's not just microorganisms that people are moving around the globe. We move around plants, we move around animals. Sometimes we do this purposefully, and probably a lot more often we do it by accident. It's estimated that on any given day, more than 10,000 species are being moved around the world just in the ballast water of our supertankers. Mostly the results go unnoticed. The species that's being moved to a new place can't survive there, or it doesn't reproduce. But sometimes the results are so world-altering that we cannot help but attend to them. And the more species we move around the planet through global trade and global travel, the more of these impossible to overlook events we're going to get. I'm just going to mention a couple of examples. There are thousands of instances. In fact, there are whole databases full of them. Hawaii used to be home to about 100 native species of these very lovely tree snails. The snails were found nowhere else on Earth, and they made up their own subfamily. When people introduced non-native species to the islands, they devastated the native snails. So now there are only about 25 species of these snails left, and most of these are critically endangered. The Guam flycatcher is a bird, and the Guam flying fox is a bat that were both driven to extinction by the introduction of the brown tree snake, which was probably a stowaway in military cargo brought to the island during World War II. This is a pair of birds called hui. They're really interesting birds. As you can see, this is presumably a pair, a male and a female, and they have these wonderfully different shaped beaks that were presumably used so that they could work in tandem to hunt different kinds of bugs. And this is a bird, this is a Stevens Island wren. And the Stevens Island wren was another really interesting bird. It was one of the only flightless songbird known to have existed. So these are just two of a whole slate of New Zealand bird species that were driven to extinction with the introduction of European predators like rats and weasels. So as I said, this list could go on and on and on. We humans think of moving organisms around the globe as very ordinary. Many of the plants in our backyards come from other continents, as do many of the crop plants and the domesticated animals that we consume. But when we look at this from the perspective of other creatures, from the perspective of a Hawaiian snail, say, or a Guam flycatcher, or a hui, the process looks very different and very out of the ordinary. Over most of the course of evolutionary history, plants and animals didn't just show up on new continents or new oceans. Or if they did so only very rarely, perhaps as a result of a tsunami or some other very violent event. Because without a lot of help, a land animal can't cross an ocean, and a marine creature can't cross a continent. Charles Darwin was very interested in the obstacles to the movement of plants and animals because he realized these were what accounted for the diversity of life on Earth. Different land masses evolved different flora and fauna, even if their climate and topography were very similar. And the same was true for different bodies of water. So Darwin was, of course, writing in the days before plate tectonics and molecular biology. Nowadays, we have a much better idea of how long various land masses and lakes have been cut off from one another, and so have been evolving separately. New Zealand, for instance, has been separated from the nearest large landmass, which is Australia, for 80 million years. And in that time period, a very distinctive fauna evolved on New Zealand, one in which birds occupied the ecological niches usually filled by mammals. Until the Maori arrived around the year 1300, New Zealand had no terrestrial mammals. And now it has not just rats and weasels, but mice and rabbits and cats and dogs and hedgehogs and ferrets, and of course people. A lot of New Zealand's birds were flightless, and they had no defenses against these introduced mammals. So many of the native bird species that remain, and many have already gone extinct, like the two I just showed you, they are in big, big trouble, and this includes the country's iconic kiwi. 250 million years ago, toward the end of the Paleozoic era, all the world's landmasses were squished together into one giant supercontinent called Pangaea. And today, biologists point out that we are, in effect, creating a new Pangaea by bringing together all the world's flora and fauna. And this reshuffling of the biosphere, this creation of a new supercontinent, is a development that is unprecedented in Earth history. It took many millions of years to form the original Pangaea, and here we are putting the new one together in a matter of centuries. So we are, in effect, running geological history backwards and at warp speed. And this rearrangement of the biosphere is one reason that scientists argue we no longer live in the Holocene, the time since the last ice age, but have entered a new epoch, the Anthropocene, the age of man. And whether this new nomenclature should be formally adopted is still a matter of debate, but the term has already been adopted informally. I'm sure you all have heard it, and it appears all the time now in both popular and scientific publications. And this represents, once again, when you think about it, a really basic and disorienting shift in how we have to think about ourselves. So thinking scientifically about man's place in the world used to mean acknowledging our insignificance. Darwin's mentor was Charles Lyell, and he taught us that the time in which we live is not in any way special. The Earth has been around for eons, and the same processes of geological change, erosion, for instance, or volcanism that shape the planet today were shaping it already in the days of the dinosaurs. And Darwin extended that view. He taught us that our species was just another species. Like every other living creature, it had evolved slowly from more ancient forebears. And even the qualities that seem to us to set humans apart, love, say, or a sense of right and wrong, must have arisen just as other adaptive traits did through the process of natural selection. But the Anthropocene forces us to turn this around, to see ourselves once again as different, as remarkable, as even unique. Because no other creature in the history of life on Earth, and this history goes back, we now know, at least 3.8 billion years and maybe longer, has ever dominated the planet as we do now. No creature has ever changed the Earth at the rate that we are changing it right now. This is true whatever we do, whether we start a nuclear war or don't start one, whether we replace our coal plants with wind turbines or our gas-powered cars with electric ones. Here I am quoting from a book called Global Change and the Earth System, A Planet Under Pressure, written by a team of Earth scientists. There is no evidence from paleo records to indicate that the Earth has ever experienced simultaneously the wide range of changes in both magnitude and rate in so many different aspects in the global environment that it is experiencing now. Human-driven changes are pushing the Earth beyond its natural operating domain into planetary terra incognita. This, as I'm sure you all recognize, is a coral. Specifically, it's a colony of coral called Acropora millipora, which is a very common species on the Great Barrier Reef. So corals are animals. They're colonial animals that resemble humans in this one respect. They're great engineers, great builders. Corals construct reefs by excreting calcium carbonate. Hundreds of billions of individual corals working at this project generation after generation create these enormous structures. And these creatures are crucial to marine life. In the tropics, the oceans tend to be very low in nutrients, and this is because the water doesn't turn over very much. It's very stratified. And water that's low in nutrients should be, and generally is, low in life. But coral reefs, as anyone who's ever visited a healthy reef knows, are full of life. The density and diversity of life on a healthy reef may be greater even than in a rainforest. And the reason for that, it seems, is that reefs are like bazaars where all sorts of creatures congregate and swap with each other what they need to survive. So corals themselves are models of cooperation. They house these tiny one-celled plants, tiny algae, in their cells, and the little plants use the nutrients that the corals excrete, and in return, these algae provide a lot of the coral's food. So corals are among the many creatures on our planet that lack eyes. Instead, many species have these special light-sensitive cells, and that is, at least in part, how they coordinate these amazing spawning events that take place once or twice a year. So during these events, many species release these little bundles that have sperm and eggs in the same little convenient bundle. And these events always take place after a full moon. So I was actually fortunate enough to be on the Great Barrier Reef a few years ago for a spawning event. And it was a little bit like being inside a giant snow globe. It was an amazing experience and a glimpse into another world, a world where humans are outsiders and where human senses are not terribly useful. So even though corals are relatively simple creatures, or perhaps because they are relatively simple creatures, they are very sensitive to changes in their surroundings. And there are all sorts of ways that in the Anthropocene they are suffering. Corals thrive in clear water. If the water becomes turbid or if it gets silted up as a result of, say, deforestation, they can't cope with that. Overfishing is also a big problem for them. Grazing fish eat algae that compete with corals for space. So if the grazers are gone, the algae take over. Agricultural runoff, too, is a big danger for them. It contains a lot of nutrients, and corals, as I mentioned, they like nutrient-poor water, so the runoff favors the algae growth, and the corals lose out. Those are some of the local threats that affect individual coral reefs. And then there are the global threats. One of the hallmarks of the Anthropocene is that we are changing the conditions of life everywhere at once and in many different ways simultaneously. So corals like warm water, but they don't like very warm water. And when water temperatures spike beyond a certain range, and that range differs species to species, their plant symbionts go into this sort of photosynthetic frenzy, and they produce dangerous quantities of oxygen radicals. So the corals expel them, and as a result, they turn white. This is the phenomenon that's become known as coral bleaching. And without their plant symbionts, the corals aren't getting enough to eat, and so they essentially start to starve to death. And sometimes they bounce back from this, and sometimes they don't. Ocean temperatures are rising very quickly owing to climate change, and so bleaching events are becoming more frequent, and they're becoming more severe. There was a very severe episode on the Great Barrier Reef this past winter, which was their summer, And this followed a severe episode in the winter of 2016. And I'm just going to show you a short video clip. This is of an Australian scientist, Terry Hughes, who has been very outspoken in sort of trying to raise the alarm here. And he is flying over bleached sections of the reef. And I think this gives you a sense of how extensive the damage was. When we burn coal and oil and natural gas, we are taking carbon that was buried underground and releasing it to the air. So this is another way that we are, in effect, running geological history backwards and at a very high speed. We're taking carbon that was sequestered over the course of hundreds of millions of years, and we are throwing it back into the atmosphere in a matter of centuries or even really decades. And this is not just warming the planet, it's also changing the chemistry of the oceans. So as Ayel mentioned, a lot of the CO2 that we put up into the air very quickly is absorbed in the surface waters of the ocean. And when it dissolves in water, carbon dioxide forms an acid, carbonic acid. So we are acidifying the oceans, and acidified water makes it more difficult for corals to complete these vast construction projects of theirs. And at a certain point, if we keep going on this trajectory, it will become impossible. So if Chytrid looks to frogs like a kind of biological warfare, then ocean acidification probably looks to corals like a kind of chemical warfare. Scientists who have looked at this issue very carefully, both in lab experiments and in field experiments, predicted the whole reef building project, which has been going on for millions and millions of years, may be coming to an end once again everywhere and all at once. Instead of reefs, we're going to have what one scientific team described as rapidly eroding rubble banks. It's estimated that about a quarter of all marine species spend at least part of their lives on a reef. Something like 50,000 reef-dwelling species have been described, but probably there are another million, and perhaps there are several million waiting to be cataloged. And all these species are put at risk by the destruction of the world's reefs. Already close to 80% of the coral cover in the Caribbean has disappeared. The casualties will range from very tiny creatures, like this shrimp, which happens to be a newly discovered species from Indonesia that was named after Elton John. Yeah, apparently the guy thought his claws sort of looked like Elton John's shoes, I guess. To these larger and more charismatic species, like these fantastic butterfly fish from Australia. So everyone here, I'm sure, is familiar, has seen this photo before. It's the famous blue marble shot, the first complete image of the Earth, an image that's often said to have marked a turning point in our relationship to the planet. This is the way NASA puts it. On December 7th, 1972, the crew of Apollo 17 changed the way we look at our home planet. This photograph illustrates the Earth as an isolated ecosystem floating in space. Neil deGrasse Tyson has made much the same point. The space program's unprecedented images of Earth compelled us to think deeply about our dependence on nature and the fate of our civilization. Seeing the Earth as small and lonely is one of those shifts in perspective that rattles us out of our complacency. And one way to read Jonathan Schell's work and Bill McKibben's work is as an effort to drive home this basic insight. The world as we know it is a fragile place. The blue marble perspective, which is looking down on the Earth from an altitude of more than 20,000 miles, is, of course, not a coral's or a shrimp's or a frog's. It seems safe to say that, shown this image, not even our very closest relatives, the chimpanzees, would have any idea what they're looking at. To appreciate something so abstracted from lived experience is a singularly human talent. So is raising the question, what is the fate of the earth? But if Tuffy, say, or a hui, or a Stevens Island wren, or a butterfly fish, or a kiwi, or an elephant, or a wolf, or a Leucothoe eltoni could ask that question, I think I know what their answer would be. It's not nuclear war exactly, nor is it climate change exactly. It is us. We are the fate of the earth. Today, the biomass of the Earth's human population is estimated to be 10 times greater than the combined biomass of all the planet's wild mammals, and I use the term wild here advisedly. Meanwhile, if we look at the weight of our domesticated animals, cows and goats and pigs, the situation is even more extreme. Their biomass is roughly 25 times greater than that of wild mammals. And if you add us and our beasts together, the ratio is 35-1. In numerical terms, we are a hugely successful species, an astonishingly successful species, and our success has come at the expense of other living things. In October 2017, it's easy to worry that the human project is in danger. From the perspective of other species, though, what's scary is not the fragility of human life, but its remorseless vigor. We should attend to the fate of the earth for our own reasons. The greatest threats that we face today, nuclear war, climate change, these are almost easier to accomplish than they are to envision. But as important as we are to ourselves, we are not all that there is on this blue marble. And if we are just thinking about ourselves, then we are failing as ethical agents, which is to say, as human beings. Thanks very much.